Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here is 2019 paper 2 question 9. In this question we're given the triangle SGH, and within the triangle is a helipad in the shape of a circle. We're told that GH is 30, that HS is 58, and that the angle GHS is 68. The first part of this question asks me to find the distance SH. Well, this is a relatively straightforward question. If you know two sides of a triangle and the angle in between them, then you can just use the cosine rule to get the other side. The cosine rule is that a squared is equal to b squared plus c squared minus 2bc cos a. The only thing you have to be careful of here is obviously the small letters, the a, b and c, stand for the three different sides. The capital A is the only angle we're dealing with. So obviously the angle I'm dealing with is 68 degrees. Whichever angle you're using, the opposite side has to be subbed in as the side A. So in this case, A has to be the side SG, or in other words, the unknown, the thing I'm looking for. And then B and C are interchangeable. It doesn't matter which one is B or which one is C. So you'll notice I've plugged them in here. I've assigned the 30 meters to be B and the 58 meters to be C. We just plug it all in and it works out as SG is equal to 54.4 meters. And that's your final answer for this part. So we've worked out that the three sides are 30, 50 and 54.4. And the second part of this question, we're asked to find the angle HSG. Now we're dealing with a non-right angle triangle, so obviously we need to use either the sine rule or the cosine rule. And in this case we actually have enough information to use either one. In general, a good rule of thumb, if you know a side and its opposite angle, your best bet is to use the sine rule. So in this case, because I know the side SG and I know the angle opposite it, my best bet is to use the sine rule. The sine rule says that a side over the sine of the opposite angle is equal to another side over the sine of the opposite angle. So in this case, what I'm using the side SG over the sine of the opposite angle, which is 68. So that's 54.4 over the sine of 68 is equal to the side GH over the sine of the opposite angle, which is the angle I'm looking for, at HSG. So obviously you have to use the 30 there. If you had used the 50, you would have got it wrong because you would have ended up finding this angle. So you just have to recognize the relationship between sides and opposite angles. It's 54.4 over sine 68 is equal to 30 over the sine of my angle that I'm looking for. So here I've just got two fractions and an equals in between them. If you've one fraction on the left, one fraction on the right, the easiest thing to do is to just cross multiply. So if I cross multiply here, I just get 54.4 times the sine of my unknown angle is equal to 30 times the sine of 68. In order to get the sine of the angle on its own, at this stage we divide both sides by 54.4. If I divide both sides by 54.4, I get this fraction. In order to get the angle on its own, I get sine inverse of that fraction. So notice here that I haven't actually used my calculator at all yet. And I think in these kinds of questions where you're dealing with complicated trigonometry, usually you're better off not to use your calculator until the very end, or at least try and minimize your use of the calculator. Because every time, like if you had plugged in sine 68 here, you would have rounded it off. You would have rounded it off to 3 or 4 or 5 decimal places, but nonetheless it's not as accurate. Here I'm going to get a really accurate answer because I'm not rounding off at all. When you plug that into your calculator, your final answer to 2 decimal places is 30.75 degrees. In the third part of this question, we're asked to find the area of the triangle SGH corrected 2 decimal places in meters squared. So whenever you get an area, I'd always just be on the lookout. Are they playing around with units? But they're not here. They've given, all my things are in meters and they've asked me for the answer in meters squared. So the 30 and the 58 are fine. Now we have a lot of information. I've only marked in the information we need here. In order to get the area of a non-right angle triangle, you have to use the formula a half a times b times the sine of c. Now just bear in mind that obviously the angle we're talking about, obviously the capital letter here is the angle. So that means that this is my c in this case. Which means the side opposite it would be the small side c, which means this has to be the side A and that has to be the side B. All I'm trying to stress here is, in order to get the area of a triangle, you have to use the angle and then the two sides around it. You cannot use this side. If you're using the angle 68, you have to use 30 and 58. Previously, we've worked out that this angle is 30.75. If you want to use that angle, you would have to use this side and this side. You'd have to use, we've worked that out previously as well. If we were using this angle to get the area, that'd be the angle, and we'd use this side and this side. But just be aware, I've decided to use the angle 68, and that means I have to use the side 30 and the side 58. So the area is a half by A by B by the sine of C. If you plug it all into your calculator to two decimal places, the answer is 806.65 meters squared. In D part 1, we're asked to get the area of the triangle PHS. So in other words, this triangle here. Now it's really important, I want you to compare this one to C. In C, it's a non-right angle triangle just like C was. And in C, we used a half AB sine C. Now in this case, I'm going to use a much easier formula. In order to get the area of the triangle PHS, in this case, I'm going to use a half the base by the perpendicular height. The reason I can use this time is because I know the perpendicular height is OR. Remember that HS is clearly, it's a tangent to the circle, so I know that HS is perpendicular to this radius that's been drawn. So because I know the perpendicular height, I can use the formula half by the base by the perpendicular height. In part C, I wasn't able to find the perpendicular height. I didn't know what the perpendicular height of GHS was, so I couldn't use this formula. I had to use the harder one, which was a half AB sine C. But in this case, it's far, far easier. The base is 58 meters. The perpendicular height is OR, which means if I just sub into my formula, it's just a half by 58 by OR. Half of 58 gives me 29 OR meters squared. And that's your final answer for D part 1. In D part 2, we're asked to show that the area of the triangle SGH can be written as 71.2 OR. Now in part C, we've already found the area of the triangle by using half AB sine C. Clearly, in this case, I have to do it differently. D part 2, you should assume D part 2 is related to D part 1. In D part 1, we worked out the area of SHP in terms of OR was 29 OR. If you look at the whole triangle, we could say that the whole triangle is just the addition of these three triangles together. The triangle HSP plus the triangle HPG plus the triangle GPS. If you add those three triangles together, that's the total triangle. This is just splitting the big one into three. By using the same method we used in D part 1, I can get the area of these three triangles in terms of OR. And when I add them together, I'm hoping I get the answer I'm looking for. In each case, you can get the area of all three of these triangles by half the base using half by the base by the perpendicular height. We've already done it for HSP, it's 29 OR. For HPG, it's a half by 30 by OR, which is 15 OR. And for GPS, it's a half by 54.4 by OR, which is 27.2 OR. If I add 29, 15 and 27.2, I get 71.2 OR meters squared. So happy days, I got the right answer, that's what I was looking for. For D part 3, we're asked to find the value of OR to one decimal place. Now this is very straightforward, because in C, we worked out the area of SGH was 806.65. And in D, we've worked out that the area of SGH can also be written as 71.2 OR. So I just let the two answers equal to each other, and then all of a sudden I got one equation, one unknown, I can find OR. In order to get OR on its own here, all I need to do is divide by 71.2. So 806.65 divided by 71.2, my final answer for OR works out as 11.3 meters. And that's your final answer there. In the final part of this question, we're told about a vertical pole ST. We're told that the angle of elevation from the helipad or from P is 14 degrees. And we're asked to calculate the distance ST. So ultimately that's what we're trying to find. But we don't have enough information to do it yet. In order to find ST, obviously we need more information here. First of all, it's mentioned it's a vertical pole, so we're dealing with a right angle triangle. We need at least two pieces of information in this triangle. From the information we already know, we can deduce what PS is. So we're looking for the opposite, and we can figure out what the adjacent is. So the last thing we're going to do in this question is we're going to say that the tan of 14, the tan of this angle, is the opposite, which is ST, over the adjacent, which is PS. So now that we need to look at the original triangle and see if we can figure out a distance for PS. Okay, so in order to find the distance PS, we need to go back to the original triangle GHS. And what we need to do is, well, obviously, first of all, I need to form a line PS, okay? And I need to form a shape that will allow me to find the distance PS. What we need to do in this case is we need to draw a line from the center of the circle to the point of contact of the circle and the line HS. The point of contact of a circle and a line, obviously at that point, that means that HS is a tangent to the circle. So if HS is a tangent to the circle, we know from our geometry that at the point of contact, the tangent and the radius form a right angle triangle. In the previous part of the question, we worked out that the radius of this triangle was 11.3 meters. So I know that that distance is 11.3 meters, and I'm going to use it to try and find the distance PS. So we need to consider what other information we have about this right angle triangle. To make life easier, let's just refer to this as the distance x. So we're talking about the right angle triangle PXS. Now, in order to find a piece of information in a right angle triangle, I'm going to need at least one more piece of information. I've no way of working out what the distance XS is. So I can't find another side, but I should be able to find another angle. Remember from the second part of the question, we worked out that this entire angle was 30.75 degrees. The second part of the question, we worked out the angle HSG was 30.75 degrees. And we can use that in order to figure out this angle. There's a bit of theory here. You might just think it looks like you can divide it by 2, which we actually can. We are allowed to just divide the entire angle by 2 would give me this one. But there's a reason for it. If you have a circle inside that's touching the side of if it's touching all three of these sides, that's the in circle. It's a circle inside a triangle. You should remember from your constructions that in one of our constructions is to construct an in circle. A circle inside a triangle that touches all three sides. In order to construct the in circle, we need to find the point of intersection of the angular bisectors. In other words, we bisect all three angles and the point where they meet is the center of the circle. Or in other words, what I'm saying is that this line, the line S going through P and continuing on, that's an angular bisector. It bisects this angle. If I drew a line from H to P and went through it, that would bisect this angle. But by virtue of the fact that this is an angular bisector, I can say that the angle PSX is just half of this entire angle. We worked out that the entire angle in part 2, we worked out it was 30.75. So to work out this angle, we just divide 30.75 by 2. If we divide 30.75 by 2, we get 15.375 degrees. So now I know that I could say that this angle, the angle XSP, is 15.375 degrees. Once I know this angle and I know this side, I can use junior cert trigonometry to find the angle PS. I know this angle and I know the side opposite it. And the side I'm looking for is the hypotenuse. I know it's the hypotenuse because it's opposite the right angle. So I know the opposite and I'm looking for the hypotenuse. So I need to think of whether I'm dealing with sine, cos or tan. If I'm dealing with the opposite and the hypotenuse, then clearly I'm dealing with sine. I know from my maths tables that the sine of an angle is the opposite over the hypotenuse. So I could say that the sine of 15.375 is equal to the opposite, which is 11.3 divided by the hypotenuse, which for the moment is my unknown. Let's just keep calling it PS. Now I've got one equation and one unknown, which means I'll be able to find the value of PS. In order to eliminate my fraction, I would multiply both sides by PS. If I multiply both sides by PS, I end up with PS sine 15.375 is equal to 11.3. Now obviously my goal here is to find PS, or in other words to isolate PS. So if I isolate PS, I'm going to divide both sides by sine 15.375. So PS will be 11.3 divided by 15.375. And if I plug all of that into my calculator, my final answer for PS works out as 42.62 meters. Now I'm rounding that off to 2 decimal places, but I get 42.62. Once I know this, I can go back to the original diagram, I can go back to the triangle PST, and it'll be relatively straightforward now to answer the question. Okay, so let's go back and finish this one off. Originally, we were given the triangle PST, and we were told that the angle TPS is 14 degrees. We're after working out that the side PS is 42.62. This is going to allow me to answer the question, which was to find the distance TS. Again, you need to recognize that we have a right angle triangle, so we're just dealing with junior cert trigonometry. I know this angle, and I'm looking for the opposite, while I know the adjacent. So I'm dealing with opposite and adjacent, and I know from my trigonometry that means I'm dealing with tan. I know that the tan of an angle is the opposite over the adjacent. So in this scenario, I would say the tan of 14 is the opposite, which is ST, over the adjacent, which is 42.62. And at this stage, you've got one equation and one unknown, so we can find the value of ST. In order to eliminate my fraction here, I just multiply both sides by 42.62. If you do that, you get 42.62 tan 14 equals ST. If you plug that into your calculator, you get 10.6 meters. They asked you to leave your answer to 1 decimal place, so your final answer there is just 10.6 meters. So I hope all of this video makes sense. If there's anything you're unsure of there or you'd like me to clarify, just send me an email or let me know in class and I'll try and explain it differently.